Well, I'm an environmentalist at heart. Originally, growing up as a kid, I've always been really interested in the sea and been involved in marine sports throughout my life. So I've developed a real passion for the marine environment, especially around the UK. Our seas and coasts have been heavily developed, both onshore and offshore. We need to understand how these developments impact the marine and coastal environment. Integral to this environment is sediment. Now more than ever, particle tracking, tracing the movement of sediment, is crucial. So my project is titled The Development of Particle Tracking Technology. I work with a company called Partrac Consulting Limited, who have developed a unique environmental tracer. Everything goes somewhere. A tracer is able to show where something comes from, how it travels, and where it finally ends up. So as you can see, that is completely 100% magnetic.
That's amazing. Have you taken any measurements of the magnetic susceptibility?
Dr. Kevin Black at Partrac Consulting is a leader in the field of particle tracking, so to have his expertise and support throughout the project is really beneficial.
Partrac is a marine environmental consultancy. We were formed 10 years ago. We're just into our 11th year now, and we specialise in the collection of data. Most of our clients are commercial clients, so we have people building offshore wind farms, people building tidal energy farms, dredging companies who are dredging estuaries. And for many of these large projects, they need data because it's principally required by the government, because it's environmental monitoring and they're having an impact. Historically, tracing studies have been done to monitor and define the movement of sediments using a fluorescent tag. So people have taken some beach sand and dyed it red, and it's fluorescent, which means it will glow under ultraviolet irradiation. What we've done is we've taken that fluorescent tagging methodology and we've made the sediments magnetic as well as fluorescent at the time of manufacture. And now those two labels or tags are used then to identify unequivocally the tracer in the environment.
The tracer is deployed to the site being investigated. After a period of time, you return to take samples from targeted areas of the site. Because I'm using a unique magnetic tracer, it's possible to use just a simple magnetic separation technique to determine the mass or the concentration of tracer particles within each sample. This data can then be used to understand where the tracer has moved from, where it has ended up, the pathway it has taken, and the rate it has moved at. Using this technique shows us how sediment is moving within a site. So we're starting off from a point with a really strong, unique tracer. And now I want to refine each step of the methodology to develop a strong methodology to be used with that tracer.
Jack's gone right through the whole methodology in relation to measuring how much tracer is contained in a sample. So he has succeeded in refining that. And in fact, he's brought the method on. So if we have two colours on a beach, if we put red sand down and green sand down, we can measure the amount of red and green sand in a same sample. And that is a substantial advance.
The major benefit of this is that you can investigate two different areas at the same time. So for instance, if you imagine that you were investigating a source of contamination, you could have one area with green tracer particles and one area with pink tracer particles, and ultimately investigate which is the source of the contamination. And another advantage is that you can investigate the difference in transport between a coarse particle and a fine particle. So if you're able to tag the coarse particle with one colour and the fine particle with another colour, it's possible to investigate the transport of both size sediments at the same time. One of the crucial things with my research was to reduce analytical timescales, so how long it takes to analyse a single sample, to ultimately work out how much mass is in each sample. Once you can reduce analytical timescales, you can collect a lot more samples from the field.
And now if we can process more samples, the entire methodology of working out where sediments are coming from and going to is improved, and it's far more cost effective, which from our perspective means it's more commercially viable and it's cheaper to our clients.
Working with industry and seeing direct application of your work is fantastic and incredibly rewarding to see the hard work that's going on in the laboratory being applied to commercial projects that have been used worldwide.
In terms of the university here, we've got to know members of staff in the university as co-supervisors of Jack's project, and we would like to continue that relationship. And we're very much into partnering with the universities for research projects, perhaps in this area, but in other areas as well.